In example 1, we had the equation and we had to produce the graph. In example 2, we have the graph and we have to create the equation. And so if we think about our technique DAB-C, if you were graphing, the very first thing you would have graphed was the center line. Now that the graph is there, can you see that the center line is at y equals 1? And so that tells us that our d value is equal to 1. The second thing you would have graphed if you were doing DAB-C is you would have marked your maximum and your minimum using your amplitude. Well, our maximum is at 6 and our minimum is at -4. If we were using our amplitude, we would have gone from our center line up to 6 and from our center line down to -4. What distance did we go? 5. And so we can say that our amplitude is going to be 5. The next thing, if you were graphing, is you would use your b value to find your period, and then you would draw your period on your graph. This time we have our graph. We can find our period by saying, choose either a maximum or minimum. I can see 2 minimums on my graph. What is the distance between here and here? Because this is going to be my period. How long it takes to repeat itself. Couple of ways you could figure this out. You could say, oh, it goes from here, which is at pi over 12, all the way to here, which is hard to figure out. Or you could figure out that one of these lines in this example is pi over 12. If I go from this minimum to this minimum, I go 1, 2, 3, 4, 5, 6, 7, 8. 8 pi over 12s, which reduces to 2 pi over 3. If my period is 2 pi over 3, remember we have these formulas. We have these formulas that say our period is equal to 2 pi over our b value, or our b value is equal to 2 pi over our period. So we know the period, and most students will do this. They'll take the one that b is already solved for, and they will say b is equal to 2 pi divided by my period is 2 pi over 3. Dividing by a fraction means multiply by the reciprocal. The 2 pi's nicely simplify. And my b value is equal to 3. The other thing that can be done to figure out your b value, if you know your period is 2 pi over 3, and your formula says your period is 2 pi over your b value, and I have my period is 2 pi over 3, can you just see by observation that if it's in this form, and it's only if it's in the form 2 pi over something, that you could just see by observation that b has to be 3. That would be a lot shorter than multiplying by the reciprocal and all that. Finally, with a sine graph, you would have graphed your sine graph with your d, your a, and their b value, and then finally you would have shifted it. To figure out where you shifted it, you have to say, well, where does a sine graph start? A sine graph starts in the middle on your sinusoidal axis, on your center line, going up. Can you find a point on your center line going up? We have one right there. It's on the center line going up. What does that mean? That means we've gone 1, 2, 3. Three pi over 12 to the right. And so our equation, now that we've figured out A, B, C, and D, we can write our equation. It's going to be y equals, we know that our amplitude is 5. Sine, we know that our B value is 3. We're shifting 3 pi over 12, which is pi over 4 to the right, so that would show up as minus pi over 4. And our center line is at 1, so we'd have plus 1. This question said write an equation because there is more than one right answer. If you wanted to write another equation, is there any other points where it's on the center line going up? You could have done a bigger translation. How much would that have been? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 12 to the right. So another possibility, or could have been almost identical, but going 11 pi over 12 to the right. What about if I wanted to start here, going down? What would make a sine graph start going down instead of going up? A negative, a reflection over the x-axis, changing your y values to negative. So another possibility is having a negative out in front. The b value stays the same, and now your starting point is pi over 12 to the left, and d value stays the same. So our amplitude is always 5, but sometimes you can have that negative in front to show that a sine graph starts going down. Did this have to be a sine graph? I mean, the question asked for a sine graph, so in that case, yes. But could we write an equation for this with a cos graph? Where does a cos graph start? At a maximum. Do we have any maximums on here? Sure enough, we have a maximum right here, 1, 2, 3, 4, 5 pi over 12 to the right. So I could have also written it with cos. Even though the question said with sine, I could write it with cos. Everything is the same except for where it starts. And sometimes on exam, they'll say write two equations, one with sine and one with cos. Because every time you can write it with sine, you could also write it with cos. Questions for practice are 4, 5, 6, and 7.